Hello and welcome back. In this video we'll be looking at the material in homework 3, which is on rounding ratios and percents. So let's start with a little story. If Casey has 12 eggs and Grant has 6, it's easy to see that Casey has twice as many eggs as Grant. So what we're doing is we're comparing how many eggs each person has. And when we're looking at this, what we're doing is we're looking at the ratio. So 12 eggs is twice as many as 6 eggs. So the question is, how do we come up with this twice here? So the ratio of Casey's eggs to Grant's eggs is going to be 2. Where does that 2 come from? Well, if we take 12 eggs and we divide it by 6, we get 2. So this is how many more eggs I have than Grant. It's going to be twice as many. So this is where the 2 comes from. We end up taking 12 and we divide it by 6. And this is called a ratio. We can find all sorts of ratios. So for instance, let's look at the ratio of the tallest building in Montana, which happens to be the first interstate center in Billings, which is 272 feet. Versus the tallest building in New York, which is the One World Trade Center, which is 1776 feet. I think they chose that specifically. So when we want to find the ratio between two numbers, what we do is we divide them. So we take the ratio of 272. The first number is always going to be on top of the fraction, and we're going to take the next number on the bottom. So we always take the first number on top, the second number on the bottom, and this is our fraction. This is what we want to divide. We want to take 272 and divide it by 1776. This is not something I can do in my head. I would pull out a calculator. Luckily, I did this ahead of time, and I found that this was 0.153153153, and it kind of goes on forever. But when we look at this number, we can kind of see that we don't really need all of the numbers. What's most important is going to be the numbers closer to the front. So rather than writing down infinitely many 1, 5s, and 3s, we're just going to cut this off by rounding it. So when we round something, the reason that we do so is because our numbers are so long that it's kind of hard to see everything at once, and we only want the important information. So let's see how we would round some values. So let's give some places these names. So the first place after a decimal, this is called the tenths place. And the tenths place, again, like I said, is always the first number after the decimal. In this case, this is 2. The hundredths place is the next number. So this is going to be the 3 here. And then the next number after that will be the thousandths. So if we look at the number 1.234556 and so on and so forth, the first number, the 2 here, is going to be in the tenths place. The 3 is going to be the hundredths place. The 4 is going to be the thousandths. We can go further. We can talk about the 10,000ths, the 100,000ths, the millionths place, and so on. We're going to focus on these first 3: tenths, hundredths, and thousandths. So when we want to take a number, so I have this number again down here. When we round it to the tenths place. So for this first one, what we want to do is we want to look at this first place after the decimal. This is the tenths place. And this is how big or how much information we want to display when we round to this place. So if I just write 1 point, okay, so I want to stop here. So the question is, what number do I put in there? We determine this by seeing, okay, is this number going to be closer to 1.2 or 1.3? If it's closer to 1.2, we'll put 1.2. If it's closer to 1.3, we'll put 1.3. How do you tell if it's closer or not? You look one place more at the 3, and we go, is 3 less than 5 or greater than 5? And since it's smaller than 5, we're going to put a 2 there. Okay. And I think this is best with just lots of examples. So let's look at the hundredths place. So here's the hundredths place. So when I round this number to the hundredths place, I kind of want to think, oh, I only want the information before this hundredths place. So it's going to be 1.2, and then I have to see, is this closer to 1.23 or 1.24? Do I round up or down? And here we're going to go down because 4 is less than 5. Okay. And then let's do the thousandths place. So again, we come out to the thousandths place. So this is going to be three places after the decimal. This is going to be 1.23, and then I have one last number that I need to put here for the thousandth place. And it's either going to be a 4 or a 5, and I just have to choose. Do I write a 4 there, or do I write a 5 there? And for this, what we do is we look one place more, and we decide, is this less than 5 or bigger than 5? And this is the one situation where we have it's equal to 5. So what do we do when it's equal to 5? We always round up. So instead of a 4, we're going to write a 5 there. Let's do another example. Maybe this one will be a little bit clearer. So here, let's round this to the tenths place. Again, here's the tenths place. So I'm going to write everything that comes before it. So it's just a 9. So 9 point something. And I'm either going to keep this 8, or I'm going to round it up to a 9. And you look at the next place, which happens to be a 7, which is bigger than 5. So we're going to round up. Cool, and that's how we round this to the tenths place. To the hundredths place, okay, let's come out to the hundredths place, which is going to be a 7. So we have 9.8, and then the question is, do we keep that 7, or do we go to 8? And again, we look at the next number, and we go, oh, it's a 6, which is bigger than 5, so we're going to round up. So instead of writing a 7, we're going to write an 8. Lastly, if we want to go out to the thousandths place, okay, so we've got 1, 2, 3, so this is the third position after the decimal. This is the thousandths place. So we're going to have 9.87 and then something. And then the question is, are we going to keep the 6, or are we going to round up? And we come to the next number, and it's a 5 again. So again, less than 5, we keep the same. Bigger than 5, we round up. But also, equal to 5, we round up. So in this time, we had to round up a couple of times because the next number was either bigger than 5 or equal to 5. Up here, when we were rounding, we kept the number the same quite often because the next number after that wasn't bigger than 5. Let's do an example where we combine ratios and rounding. So here, let's look at we want to round the ratio of 9 to 4 to the thousandths place. So first of all, we have to find the ratio, and then we round it. So the rounding should always be the last step. So let me write that down. Rounding, is the last step. We always want to round last, because sometimes if you round in the middle of a problem, your numbers change slightly, so it won't match the actual solution at the end. We always wait till the very end to round. So let's look at the ratio of 9 to 4. Okay, again, a ratio means that we're just going to divide. So I'm just going to take 9 divided by 4, and if we plug this into a calculator, we will end up getting 2.25. And we want to round this to the thousandths place. So again, thousandths place, that's 3 places after the decimal. So I have to round 2.25 to the thousandths place. Well, there isn't even a thousandths place, is there? We've got a tenths and a hundredths, but no thousandths. Luckily, there's a solution to this. What I can do is, if there aren't any numbers after this, can just add a 0. So for instance, if I just looked at the number 1 here, well, 1 is the same thing as 1.0, which is going to be the same thing as 1.00. 0, 0, 0, it doesn't matter how many zeros I add at the end. The same thing happens up here. If I get 2.25 and I need the thousandths place, I've got to have something there. So I'm just going to add a 0. So this is rounded to the thousandths place. The last thing that we'll look at is going to be percents, and we'll end up rounding percentages as well. So the way to find a percent, the percent of A to B is going to be A divided by B times 100. So when we look at this, when we take A divided by B, this is exactly the same as a ratio that we had before. So percents and ratios are almost identical. But with percentages, we end up multiplying by 100. And then you can ask, okay, why 100? Where does this come from? Well, if we think about the word percent, it has two parts. It has per and cent. And how many cents are there in a dollar? There's 100. The word cent, C-E-N-T, means 100. So that's why we multiply by 100. So let's go through an example. Let's find the percent of 3 to 6. So we use our formula. And we go, okay, so percent of 3 to 6, we take 3 and we divide it by 6. And we'll end up multiplying this by 100. 3 divided by 6, this is something that we can just plug into a calculator, and we'll see that we get 0.5. And we'll end up needing to multiply this by 100. The 100 doesn't go away. And when we multiply anything by 100, it's really nice because we're just shifting the decimal place over. So if I were to write 0.5, I'm going to shift the decimal place over twice to the right. So my decimal is going to go here, it's going to go behind the 5. And if I push it over once more, well, there's no number here, but just like we saw before, there could be a 0 there. So 0.05 is the same thing as 0.050. And when I shift the decimal place over, I'll get 50, because now the decimal place is going to be after this 0 there. And in particular, we can't forget that if we're looking at percentages, we need this little percent sign. So this is going to be equal to 50%, which is exactly what we would expect. The percent of 3 to 6, well, 3 is 50% of 6. And this is a fairly nice calculation. We all know that 3 is exactly half of 6. And half should be 50%. So we can write 3 is 50% of 6. Cool. So sometimes when we want to find percentages, the numbers aren't so nice, and we will want to round them. So again, we want to find the percent of 8 to 7 rounded to the thousandth place, the hundredth place, and the 10th place. So first of all, let's find the percent of 8 to 7, and we won't round. So again, what we do is we divide. Percent of 8 to 7 is the same thing as the ratio of 8 to 7, so 8 divided by 7 times 100%. We plug this into our calculator, and we would get something like 1.14287, and then a few more numbers. I'm just going to stop here for the moment, times 100%. When we multiply by 100, we move the decimal place over. So this decimal place is going to go 1, 2, and we'll have 1, 1, 4, then the decimal, then at 2, 8, 5, 7. And now we can start rounding. So if we round to the thousandths first, we'll have 1, 1, 4, and then 2, 8, and I stop at the 5 and I go, oh, do I round up or down? Bigger than 5, we'll round up and we'll get 6.